Question 3a says solve for exact values over all real numbers. So when it says solve for exact values, we need to have the ratios equal special value angle ratios. And we need to solve this with special value angles. So if the ratios do not equal special value angles, we cannot solve for exact values. So we should expect these equations to equal special angle ratios. So when we take a look at the equation 3a, we can see that we have a cosecant and a cotangent together. We cannot solve for two different ratios at the same time in one equation, unless we can somehow factor them apart. In this case, we can't. So what we need to do is look for an identity. So in this problem here, there is an identity of cosecant squared minus 1. And cosecant squared minus 1 is equal to cotan squared x. And what that's going to do is it's going to allow us to express this equation in terms of one trig function of cotan. So I'm going to replace this with cotan squared x. And so we end up with cotan squared x minus cotan x, and that's equal to 0. And we can solve this by factoring. So we end up with cotan x times cotan x minus 1 equals 0. And solving these two independently of each other, the cotan x equaling 0, okay, so we end up with cotan x equals 0. And since we want to convert this into tan, we end up with tan x is equal to undefined. Okay, so where is tan x undefined? Tan x is undefined where the tan is vertical, where the slope is vertical at these two positions. So these are my primary solutions. So x is going to be equal to pi over 2, and theta 2 is going to be equal to 3 pi over 2. Now, this question does say for all real numbers, so we need to have all the repetitions here. So when I do my repetitions, overall real numbers, we need to know the period of this function. So the period of this function is going to be equal to 2 pi, okay, because we don't have horizontal compression in here. So in that full circle, we have two solutions, and then the repetitions are going to happen every time we go around. So we show that with n2 pi. And we have to state that n is an integer because we're going to go up by increments of 2 pi, either up or down. So that's the solution for cotan x equals 0. We're then going to solve for this part, and we're going to end up with the equation cotan x equals 1. So we're going to convert this to tan. Tan x is equal to 1, and in our circle, we're going to have tan x equal to 1 is where the slope is equal to 1. So it's going to be through that 45-degree line. Okay, so we're going to have solutions at those 2 points. So x, I'm going to call this x3. That's going to be at 45 degrees, or pi over 4. And the last one is going to be when theta is equal to 5 pi over 4. Okay, that's our quadrant 3 angle. And so we've got the two primary solutions and exact values. We need to get all the repetitions, and the repetitions are going to be based on the period of 2 pi. So plus n2 pi plus n2 pi. So we have all the solutions here for that equation. Again, we have exact values, so we need to end up with exact value ratios. And in this case here, because we have cosecant and cotan together, we somehow have to rearrange it so that we have one trig function. Otherwise, the equation is going to be hard to isolate that one trig function. So in this case here, we use the identity cosecant squared x minus 1 equals cotan squared x, and that gave us one trig function at this point here. to be able to solve this equation.